Okay, so welcome. We skipped a section here, section 1.2 we're skipping, but there's two main ideas that I want to bring up from it. The main idea is the idea of congruence, and that is two objects that are not numbers, because we dealt with algebra, right? We had, x equals 5, 7 equals 7, things like that. We learned all these tricks with algebra. Those are all based on numbers or placeholders for numbers. Now that we start geometry, we're talking about geometric objects, a thing like a line that you could theoretically, you could hold it in your hand, move it over here, put it down, we'll name it, we'll talk about its location in space, but these are actual objects. So instead of saying object equals object, we use the word congruence to mean that they're exactly the same in every single way other than their name, okay? So exactly the same, I'm gonna switch to pink here, in every way except name. So I could rename this triangle from ABC, right? I could have a triangle ABC, and I could pick up that triangle, and I could move it over, flip it around, turn it over, but that without changing the triangle at all, I could put it somewhere else and rename it to DXM. But other than the name, if every single thing you could possibly measure about it is exactly the same, other than the name, we say those two things are congruent. Okay, in writing, we use this symbol. So I could say line segment AB is exactly the same as line segment CD, except for their names. Okay, and then over here in a picture, the symbol we use is the same number of dashes. So these two dashes and these two dashes mean this line segment here is exactly the same as this line segment. And then the single dash and the single dash means this line segment over here is separately congruent to this line segment. So they pair up when we have the same number of dashes on an image. Now, what does it even mean for line segments to be congruent? Well, since there's only one thing you could possibly measure about a line segment, right? It's a one-dimensional object. It has no width, has no height, it has no color, no thickness, anything like that. The only thing that defines it other than its name, which is its location in space, other than that, it has a length. So we say that two line segments are congruent if and only if they have the same length. So if both line segments are 7 inches long, we say they're the exact same line segment. It doesn't matter what name you give it or whether your line segment's over there and mine's over here. I could take mine and place it right on top of yours, and they're exactly the same in any way you could measure them. So line segments are congruent. So right up here, this means that the length of AB and the length of CD are the same length, right? That's what them being congruent means. Okay, so this new section is all about the midpoint and the distance formulas, okay? You've probably seen the midpoint before. The midpoint is on, hopefully that refresh. That's weird that it's going a little slow. My computer is getting old. So the midpoint is the point exactly in the middle of a line segment. Now, there is no midpoint of a ray or line because they're infinitely long. Another word you might see used in the book is equidistant, which really just means equally distant from the two endpoints. Now, I'm careful to say it has to be on the line segment for it to be the midpoint, because there are infinitely many points that are the same distance from A and B, like 10 and 10 away, or 8 and 8 away. So there are other points that are equidistant from the endpoints, and we'll talk about those in, I think chapter 4, we talk about those. But the midpoint is on the line and right in the middle. So this is 4 inches from each endpoint, and it's on the line segment, so that's the midpoint. This one over here, we don't know the length, but we do know these two line segments are congruent, so we do know that this is the midpoint right there. Okay? Now a bisector is anything that passes through the midpoint. So you could cut a line segment in half with a ray, you could cut it in half with a line, you could cut it in half with, even like if you took a triangle and rotated it, so you were looking at its infinitely thin side, because a triangle is two-dimensional. If you took it like a knife on its side, you could even have a triangle bisected. Now that gets more complex because it's a 2D object in 3D space. But for now, it's usually going to be lines or rays or something that bisects it. Now, it doesn't have to be a perpendicular 90 degrees. It could be at any angle that it passes through. Bisect only means that it cuts this line segment MN into two congruent parts. Or over in the right picture, line XY bisects line segment QP because it cuts it into two equal parts. In other words, Y is the midpoint of QP. Again, there is no midpoint of a line XY because it's infinitely long, so there's no middle of it. All right, and you could also, so bisects is like a verb. So this bisects that, it cuts it in half, cuts it into two equal parts. Or you could use it as a noun. You could say it is a bisector. So ray AB bisects and AB is a bisector are the same thing, just one's a noun, one's a verb. Okay, you could use it either way. And one important note, this is a really common mistake in terms of symbol and language as we move forward, is the difference between AB with no symbol above it and the difference with AB with a symbol above it. So if we have capital A, capital B, that's 2 points, so 2 locations in space. Between those 2 locations, we could say, well, the line segment from A to B, right, which is what's showing here. So geometric object from A to B, I'm talking about that object. Or I could say the ray or the line. But either way, if there's a symbol above it, I'm talking about a new object. An object cannot be equal to something else. I cannot take an object and multiply it by an object. That's like me saying, what's car times bird? Like, that doesn't make sense. Multiplication is defined as a number times a number. And we could use a variable as a placeholder for a number, but 6 times x is saying 6 times a number. We just don't know what that number is right now. So multiplication, addition, subtraction, all those things that come from algebra or parts of algebra are only for numbers. And what AB without a symbol above it is this is a number. You can use algebra. It represents the length of the line segment AB. So AB with no symbol above it is talking about a number. You would say something like AB equals 7 inches. Okay? Whereas down here, with a symbol above it, now it's a geometric object. So if we want to talk about it, it's the actual line segment itself. It's the actual object. So instead, if you wanted to use like congruent or something, you would say this is congruent to, and you'd actually have like maybe a picture or something. I mean, you wouldn't write it like that, but I'm just saying it is an object. Okay? It's not a number. So number, do equals, do algebra, geometric object, we talk about congruence or other relationships that we'll get into later in the book. Congruence is exactly the same, except we changed the name or where it is, right? We moved it somewhere. All right, so here's 2 examples. Okay, in this picture, we could say a few different things. Because these lengths are equal, and we know that if the lengths are the same, 2 line segments are congruent. So that's the only attribute a line segment has. So we could say that the length of QI is equal in number to the length of YP. Or we could say the length of QI, right? This is the length, this is the number, is equal to 10 meters. Or we could say that the actual line segment QI is the same as the actual line segment YP. But different things, right? Geometric object versus number. And that's a really common mistake as we get into the first quizzes, and it would look something like this. You don't want to say a number congruent to a number, or QY is equal to 10, right? Those are things you don't want to do, okay? All right, so now let's actually practice that. So when it says find AM, and this is really common on the first quiz, students are like, oh, Mr. Dilloughery, what does that mean? What does it mean find AM? Like AM's right there, right? Isn't this AM? And if there was a line segment over it, yeah, that'd be a silly question. Find it, and you just point to it and be like, it's right there. That's where the geometric object is. But when it says find AM with no symbol above it, really it's saying, what is the length of, and then line segment AM. That's what it's really asking. It's the same thing. And that's something that you need to understand on the first, quiz on geometry. There might be a question like that. And you'll say, oh, what's it asking? I'll say, that's a piece of vocab. That's a piece of the language of geometry you need to know. All right. So here, what relationship do we have? And as I said, in geometry, it's really common that the first step is understanding the language of the geometry. And then the rest of the problem is algebra. So let's look at this. Well, I see a single dash and a single dash. That tells me a couple of things. 1, M is the midpoint. 2, since these 2 line segments, AM and MC are congruent, well, that means their lengths must be the same. So I could say x plus 5 must be the same as 2x. And then once I set up that relationship, the rest of the problem becomes algebra, right? I established that those dashes means those are the same length. So subtracting x, we get x equals 5. Now, common mistake is you don't actually answer the question. So that's not what it was asking. It was saying find AM. What is the length of AM? So we go back and we say, well, AM was equal to x plus 5. That's what the length was. And we know that x is 5. So we plug that in, and we get AM was equal to 10. It was 10 long. Okay, same thing on the other problem, so I'm not going to go through and do multiple. But when it says find EM, it's saying length, question mark. And the relationship is this and this must be equal because we see the red dash that says they're the same in every way, right? Lengths are the same, everything but name. All right. Now, we talked about the midpoint in terms of geometry, a geometric object. You also might see it on a coordinate plane, okay? Now, there's a formula for this, and there's the conceptual way to understand this. I've always been a conceptual person. So for me, I like that way. So I'm going to talk about big picture. If you want to just use a formula, oh, hold on here. Lost connection. Okay, we're back. Sorry about that. For some reason, internet's cutting out here. So, back to the midpoint formula. So the big idea here is the midpoint's halfway between A and B. So what that means is, I'm going to take a really big pink, and I'm going to say what that means is we go halfway up and halfway over, because if we go some number up and some number over, and we just do that, I'm going to make it a little thinner, and we do that exact same amount up and that exact same amount over, in those two steps, we've gone the same amount each step, right? If I go up 3 and over 2, and then up 3 over 2. Obviously, this length is the same, and we did 2 steps, 2 of the exact same steps to get the whole way, so M must be halfway in the middle. So the way I think about it is I simply say, well, how much up did we go, right? Cut it in half. How much over did we go? Cut it in half, and that's where my midpoint is. So I just go halfway over and halfway up. And counting on a coordinate plane is totally okay. You can bring a piece of graph paper to a quiz. You can show your work that you graphed it and you counted. Great. Or you could think about it as the midpoint's the average, right? The average of two numbers is you add them together and divide by 2. So the formula is simply take the two x values, this one, and add them together to find what's in the middle. Then take the two y values, add them together and divide by 2 to get what's in the middle. And just a naming convention here, a lot of people get confused by this. When we call A x1, y1 and B x2, y2, all that means is I took 2 points and called 1.1 and 1.2. And I'll show you what I mean by this. So here's an example. If I want to use the formula, I know this point is x comma y, and I know this point is x comma y, but I can't use the same variable twice. Right, so what I do is I say, you know what, I'm going to call this point, point 1. So this is my first x and my first y. This is my second x and my second y. Now, know that those have no mathematical value. It's not an exponent. It's not squared times 2. It's a name. It's called a subscript, which literally means sub, below, script, right. So writing below. And that's just a name to keep track of which is my first x, which is my second x, which is my third x, and so on. So now I just plug in the formula. The formula is simply add the x's together. So x1 plus x2 divided by 2. And y1 plus y2 over 2. So that becomes 10 over 2, comma, 10 over 2. So the midpoint is at 5, comma 5. Okay. Now, personally, I like to remember things conceptually. I have a hard time remembering formulas. I mean, now as a teacher, 10, 15 years into my career, I have the formulas drilled into me. But as a student, I remembered methods much better. The idea of listening and saying, oh, that's why. That clicks. That sticks. Whereas if I'm just remembering x2 plus minus ba squared, I forget that. I mix up a sign or something. So I remember this conceptually. So what I do is I draw out a graph, or better yet, you have graph paper, and I go to 0, 4. That's my first point, 0, 4. Okay? And then I take my second point, switch out 1, 2, 3, 4, up 1, 2, 3. So here's 4, comma 3. And if I want to know what's halfway between there, I'm going to zoom in a little bit here. If I want to know what's halfway between there, I'll take another color and I'll say, well, from here over, from 0 to 4, I went to the right 4. And from 4 down to 3, I went down 1. So I'm just going to go halfway over 2, down halfway. Let's call it 0.5, even though I like fractions better. Then I'm going to go over 2 more and down the other half, 0.5. So that's halfway there. Over half of 4, down half of 1. And then over the same amount, down the same amount, we're all the way there. So my midpoint here is at, we start at 0, went over 2. And then we start at 4, went down 0.5. So there we go. So that's a conceptual way to find the midpoint. And I like that. All right. So let's go back here. Now we've got the distance formula, which again, you could remember in terms of a formula or conceptually. Here's the formula. Or conceptually, big picture is, all you do is say, well, how many did I go over? That's my A. How many did I go up? That's my B. And because X, counting left and right, and Y, counting up and down, are exactly 90 degrees apart, well, then we just use the Pythagorean theorem to find C. So we get the difference between our X's, that's our A, squared, plus difference between our Y's, that's our B, squared. Now, instead of saying the distance squared, or C squared, equals A squared plus B squared, they just take the square root, and they just say the distance is equal to the square root of how much did you go over, plus how much did you go up. And so that's all the distance formula is, right? Because if you subtract x2 minus x1, you get the distance. And if you subtract y2 minus y1, that's literally the difference between the y values. So I always remember it in terms of Pythagorean theorem, but you could use the formula. So for example, first one, let's do distance formula. I'm going to call this my xy 0.1 and this my xy 0.2. So the distance is the square root of, let's see, whoops. Whoa, that's crazy. Let's undo that. Square root of x2 minus x1 squared plus y2 minus y1 squared, so 4 minus 2 squared. So that's the square root of 4 squared plus 2 squared, the square root of 16 plus 4. Now notice, because of this horizontal bar, you have to do everything under there as a group. So this is not 4 plus 2. You can't separate the square roots like that. So this is the square root of 20, which you're done. You don't have a calculator first semester, so you can't find out the decimal value. You could approximate somewhere between 4 and 5, make up a decimal approximation, but better is leave it like that. Or if you want to simplify, we won't do this till chapter 7, but if you remember how, you could simplify the radical. You don't have to, right? But I like to do it conceptually. So over here in green, I'm going to say, well, you know what? If I want to find the distance, graph it, and go, I went down 2, and I went right 1, 2, 3, 4, 5. And so that's my A, that's my B, and my C is the distance. So A squared plus B squared is C squared is the Pythagorean theorem. 2 squared plus 5 squared is C squared. So 4 plus 25, or 29, is C squared. So my C is, just taking the square root of both sides, the square root of 29. Okay? Now, a really common mistake, as this is error analysis problem here, is often people get the two formulas mixed up, right? So to find the midpoint, we add the two numbers and divide by 2. That's the average. A plus B divided by 2 is the average. But here, instead of adding 8 plus 2 and divided by 2, they subtracted. So if you would have added, that would have been the midpoint formula. If we're finding the distance between the two, we want to know how far you went between these. We want to know what the difference is. That's why we subtract. So two different formulas, people get mixed up. And that's why I try and remember it conceptually rather than a formula, because it's easy to get a sign flipped. Okay. So let's do two last types of problems here, and that'll be it for the video. So problem number 1 is very, this is a common problem. Instead of giving you 2 points and asking you to find the midpoint, which you could just go plug into formula without thinking, brain, answer, what, and that doesn't take any creativity or problem solving. In general, we say, now that you've done that a few times, how about we take it a step further? So now I'm going to give you R, I'm going to give you the midpoint M, and I want you to project that same distance over to find the other endpoint S. So if we know this is at 3, 0, and I mean, I just made these locations up because there's no coordinate plane, where's that other point? So there's two ways to do it. One, you could use the formula, midpoint equals x1 plus x2 over 2, y1 plus y2 over 2. But you can't just plug it into here and here, because that would find the midpoint of these two, and that would tell you the location of this point. We don't want that. We want to know what the other endpoint is. So instead, we plug in the midpoint is equal to, and this is our first point, and we're looking for our second point. So we leave those as our variables. So this is equal to 3 plus something divided by 2, and my y is 0 plus something divided by 2. Google Classroom telling me a little message. Awesome. So what I'm going to do now is I'm going to say, well, if these points are the same, that must mean I could split this up or work with it as is. But I'm going to say, well, that must mean my 3 plus x2 over 2 is 0. And my 0 plus y2 over 2 is 5. So just solving like normal, multiplying both sides by 2. 3 plus x sub 2 is 0 times 2 is 0. Minus 3. So my x2 is negative 3. This is 0 plus, doesn't matter. So it's just y2 over 2. So multiplying by 2, I just get y2 is 10. So the point I was looking for is this. And you could just plug r and my newfound s into the midpoint formula and check. All right? I like to do things conceptually. So over here on 26, on a graph, I just say, well, if I start at 5, 1, here's my r, and I go to 1, 4, that's my m, I go, well, I went over 1, 2, 3, 4, and I went up 1, 2, 3. That's halfway, so let's keep going. 1, 2, 3, 4. 1, 2, 3. My new point, S, is right here. I just complete that motion. I went halfway, so just do that again. And so S is negative 3, comma 7. Perfect. Okay. There we go. That was my answer. Sorry, getting distracted by those little bings. Here's the last question. So find the length of the segment. So the length of the segment here, first we got to establish what the pattern is. Well, we go from 0 to 2 in 2 dashes. Oh, so each dash must be 1. So we could fill those in if we wanted. Then we need to say, well, if we went from negative 4 over to 3, we could either count, or you just say the big one minus the small one, or just the absolute value. If you subtract either way, it doesn't matter. And so that's 3 plus 4, or 7. So this is a 7 long. That's the length. But then here's the interesting part. It says find the coordinate of the midpoint. So when there's 2 dimensions, an x and a y, a coordinate is an x comma y. When there's only 1 dimension, we're only looking for its location in terms of what is its x value, what is its only value. And so we do the same thing for a midpoint. We just take the average of the values. So the first x was negative 4, plus the second x was 3 divided by 2. So halfway between those is negative 1 over 2, or negative 0.5. That's the midpoint. And there's only 1 dimension here because it's only an x. So that's it. Hope you enjoyed the video. Good luck.